But interestingly, it's actually not relativity that gets Einstein the Nobel Prize. Now, the young Einstein in college took with him his hatred of authority figures and structured education. So even though he did fine in college, his professors did not like him very much because he would often skip class, get the notes from his friends, and then show up for the final exam and pass the class with flying colors. And of course, his professors did not like this very much. One of his mathematics professors famously calls him a lazy dog for this. And this is fine in terms of grades, but when Einstein finishes college and he wants to get a job in physics, he can't get a letter of recommendation from anyone because his professors dislike him so much. So he searches desperately for a job. He has a young family at this point, and he ends up getting a position via a family friend as a patent clerk in Switzerland, where his job is to evaluate patent applications day in and day out. And he actually quite likes this work. He sees it as sort of an intellectual challenge, that as the patent application is put in front of him, he tries to figure out what the basic principle is that would make that machine work. And this is an approach that we'll see Einstein take over and over again throughout his scientific career as well. So he's working at the patent office during the day, and then in the evenings, he hangs out with his wife and his friends discussing intellectual issues, and he tries to do some physics on the side, even though he's not a physicist per se. E equals mc squared. C squared here is just a constant. You don't need to worry about that. So essentially, this is a statement that energy and matter are the same. So this means that energy and matter can be transformed into each other as well. But Einstein finds himself in a complicated situation here. This is still 1905, which is he has this theory that makes these extraordinary claims about the nature of space, time, energy, and matter. But he needs to convince people that he's right. And he can't conduct any experiments. No one can conduct any experiments at the time to actually measure these things directly. So the best that Einstein can do is to say that his theory is compatible with existing experiments, the most important of which is what's called the Michelson-Morley experiment. And then when he writes down the theory of general relativity, it's this equation, which is seen as an extremely elegant equation. So you can ignore this middle part here, the 8 pi g over c to the fourth, because that's just a constant, it doesn't change. Instead, pay attention to this and this. So over here we say g mu nu, and that's a measure of the curvature of space-time, how much that four-dimensional surface is bent and warped. And then over here we have T mu nu, the matter and energy in a particular place. So the equation is a statement that the curvature of the space-time of the universe is determined by the matter and energy in a particular place. Unfortunately, Einstein finishes his theory in Berlin in 1915, which is the height of World War I. So during the war, Germany is blockaded at both land and sea. And along with economic disruption and starvation, it's impossible for scientific ideas to travel as well. That is, the trenches stopped Einstein's papers just as effectively as they stopped food imports. So even though Einstein has this great new idea, very few people know about it. And it's only due to essentially Einstein's group of close friends that this circumstance changes. So the three men on the right here are Dutch physicists. And this is important because the Netherlands were neutral during the war. So Einstein was able to travel to the Netherlands from Berlin to talk. And the reason he wanted to do this is that Einstein was a pacifist and he thought the war was a terrible idea. But Imperial Berlin was a bad place to have left-wing politics. So he wasn't comfortable talking about his ideas openly. So he would go to the Netherlands, where the politics were quite a bit more neutral, as might suggest from their role during the war. And those were the people that Einstein felt comfortable talking physics with, essentially his fellow socialists. So some of them, particularly this man here, Wilhelm de Sitter, decides that people should know more about Einstein's new theory. So he writes a letter to this guy, Arthur Eddington, who's a British astrophysicist working out of London. Now, Einstein can't communicate directly because the two sides are at war. And most British physicists at the time would not even be willing to talk about German theory because it was an enemy theory. This is actually the way they talked. But Eddington was a Quaker and therefore a pacifist. So we had two pacifist scientists who were willing to get along. So Eddington, but they can't communicate directly, again, because of the war. But once Eddington hears about relativity via the Netherlands, he devotes the next few years of his life to Einstein and relativity, not just because it was hugely important science, but also because Eddington, as a pacifist, wanted to show that science should be above national rivalries and should be internationalist at its core. And that's how great science would get done. So in fact, Eddington does go find a solar eclipse. He has to travel to Africa to make this measurement at an eclipse in May of 1919. You can see here the stars that are displaced by the relativistic effect, and conducts the entire expedition and experiment without Einstein's input whatsoever, and also engineers a fantastic public relations campaign to get people excited about relativity, which is otherwise an unbelievably abstract and bizarre theory. So Einstein wakes up one morning and discovers that he's the most famous scientist in the world. So relativity makes him famous. But interestingly, it's actually not relativity that gets Einstein the Nobel Prize. And actually, in an important sense, Einstein doesn't get the Nobel Prize at all because his divorce agreement with his first wife is that she would get all the money from the prize. But Einstein is awarded the prize for one of his other papers from 1905, the one on the so-called photoelectric effect. And this was a weird phenomenon that had been known in the laboratory for some time, in which when you shine light on certain metal surfaces, electrons are ejected. And no one is quite sure at the time why this is the case. It has all sorts of strange properties. And Einstein suggests that we can explain the photoelectric effect if we think of energy not as a continuous thing like water being poured into a glass, but rather if we think about energy coming in chunks like ice cubes instead. So these chunks of energy are called quanta. So we talk about a quantum of light. And Einstein can solve various problems with this assumption that energy comes in chunks instead of free flow, as we might expect. And it's actually other people who run with this idea, in particular, a young Danish physicist named Niels Bohr, who creates the modern model of the atom. So if I asked you right now to draw a picture of an atom, you would probably draw something like this, right? This kind of planetary model. That's the model that Bohr makes based on Einstein's ideas of light quanta. And he's able to solve various problems like why there's a structure of the atom at all, why it is that the solar spectrum has these funny lines in it, and eventually becomes this larger field called quantum physics.